Hello, quick video on binomial expansions in the Mei C4 syllabus and typical questions. I picked out 3 questions here which I think encapsulate what you're going to see. The first question is looking at a fractional index to our factor. Second question has got a negative index to our factor, and the third question has a factor in the numerator and a factor in the denominator that we need to expand using a binomial. So the numerator will stay the same and the denominator will be expanded, and then we'll have 2 brackets here which we'll have to multiply together. So they all look, other than that, very similar. They all show that something equals something and find the next term and then state the values for which the expansion is valid. That's the first question. Second one is explicit. It says find the first 3 terms in ascending powers of x and then state a set of values for which expansion is valid. And the third question is also find the first 3 terms of this expansion in ascending order of x, ascending powers, and again set of values for which expansion is valid. So you can see these are very similar, these sort of introductory questions. I'm going to do one just to demonstrate what we would do, and then quickly highlight for the latter ones what the question's about and the differences. So our first question here is 1 plus, we've got to do an expansion of 1 plus 2x to the power of third and prove the first 3 terms and find the next one. Okay, so what do we need? First thing we need is a formula to use, and there's one of those in the MEI formula book. So here it is on page 2 of the formula book, and in order to use this formula we need to decide 2 things. Firstly, what's the x that's going in the bracket? And secondly, what's the value of n for the index? And we have to look at our equation, and in this case we have to match the terms. Here I've got an x inside the general equation, and here I've got a 2x in my case that my question I'm trying to answer. And for the n on the outside here, the index is n, and here the index is a third. So now we know what we're doing. We can substitute and take those values into our equation, our expansion. So let's just write that. So 1 plus 2x to the third equals, well, our first term is always 1. Our second term here is n times x. Well, n in our case is a third. X is what we had inside the bracket, that was our 2x. And I'm writing all the parts here so that we don't make a mistake. That's our second term. Our third term is going to be a third time, that's for our n. Our n minus 1 is minus 2/3. Our factorial is 1 times 2. And in our bracket for our x squared is actually substituting 2x squared. So that's our third term. And in this case, they want us to find the next. So we've got to find the fourth term. So we've got a third, that's our n minus 1 is 2/3, our n minus 2, so it's minus 2/3, it's going to be minus 5/3. And the factorial is going to be 1 times 2 times 3 on the denominator, and in the bracket we've got 2x cubed. So there's all our parts to this expansion. And then we're going to move into simplification. So our first term is 1, our second term is 2/3 of x. Our third term, well, first thing we need to look at is our sign. I've got 1 negative sign there, so my overall sign is going to be negative. On the numerator I have a 2, and from within the bracket I've got 2 squared. On the denominator I've got divide by 2, but also from the fractions I'm going to have a 3 squared, so that's going to be the coefficient of x squared. And now we need to look at our fourth term, So we look at our sign. Well, I've got a minus sign in the minus 2/3 and a minus sign in the minus 5/3. So that minus times a minus is a positive. So there we have our sign is positive. On the numerator, we have a 2 times 5 outside the bracket, and inside the bracket, we've got 2 to the power 3. On the denominator from the factor, we've got a 2 times 3, and from inside the fractions here, I've got 3 cubed. And there's my x to 3, x to the power 3. That's my coefficient for that. And I'm not interested in the other terms, so I'm just going to concentrate on those. So now going through and tidying up, I've got second term is y is 2/3, first term is 1. Fourth term in this case, well, I can cancel out 2 denominator and numerator, so I'm now left with a 4 on the numerator and a 9 in the denominator, so I've got 4/9, and that's the coefficient of x squared. And in my fourth term here, well, I've got 2 on the numerator and denominator that we can cancel out, and I don't think there's much else we can do on the top here. We've got 5 and times 8, so I've got plus 40 on the numerator, and on the base I've got 3 times 3 cubed, which is 3 to the 4 is 81. So here I've got 40 81ths times x cubed dot dot dot, and that's basically the first part of the question. They've asked us to do the expansion. Second part is they've got set the range of validity. So let's have a look at range and validity, and remember the important bit of this is what's inside the bracket. Here we had 1 plus 2x to the third, and the term here, important thing about this term is that term must have a modulus of less than 1, otherwise the terms will just expand as they go on. They'll increase in size, and therefore it won't converge. So to converge, that value must be less than 1. Therefore x, if we divide this equation by 2, gives us the modulus of x must be less than 1/2. And then if we want to write it out without the modulus sign, which is what they're expecting us to do, x must be greater than minus 1/2 and less than 1/2. So there we are. That's what we'd be expected to do in all the questions. What I would like to do fairly quickly is just outline the second question here, because of course here we're finding the expansion of 3 minus 2x to the power, that's a -3. So I'd like to just quickly take us through preparing that equation for that particular case for using the expansion. So here we have 3 in the denominator, 3 minus 2x all cubed. Now we need this first term to be 1, don't we? So the way to do that is to take 3 out of the bracket. We do that, so this equation, this expression will therefore be 3 with the 3 coming when it comes outside the bracket will be cubed, and what's left in the bracket is the 1 which we want at the front. Effectively we've got to divide the bracket, the contents of the bracket, by 3, so we end up with 1 minus 2/3 x all cubed. And in finalizing the preparation, I would look at, I've got this 3 cubed on the denominators, which is 1/27th, and then in the bracket I'm going to have 1 plus, I'm saying putting it in this way, minus 2/3 of x, because that is the equivalent, that's the substitution we're going to use for the formula. And then outside the index is -3. So now we're entirely ready to use the formula, because we know what the value we're going to substitute in for x and what the index is we're going to use as well. And what I'm going to do now is just write onto the screen the expansion very quickly so that you can see it. and here we only want the first three terms. So here we have the first three terms. First term is always 1, second term is our n, and here whatever we've put for x in our substitution, and the third term we've got our n minus 1 as our 2 factorial, and here we've got whatever we substituted for x squared. And then we can tidy this one up. So the first term here are minus 3, and r times minus 2 is plus 6. Divided by 3 gives a coefficient of 2. And the second, so the third term, we've got minus 3 times minus 4 is plus 12. Divided by 2 is 6. And then inside the bracket, we've got minus 2 squared, that's a 4, and a 9 on the bottom. And after a bit of cancellation, we get 8/3. And then our final step here would be to multiply through by the 1 over 27. So our first term is 1/27th, the second term is 2/27th of x, and our third term is 8/81st of x cubed to x squared, apologies. Here we go. And again, they're going to ask us for the range of validity. Well, the important thing is range of validity. What do we have inside our bracket? Well, we had a 1 plus minus 2/3 of x to the power minus 3, and as ever, this only works when this term here is less, it's a modulus of less than 1, so we can just write that. The modulus of that must be less than 1. Well, the sign doesn't matter here. So the modulus of x, and then multiplying out by 3/2, the modulus of x must be less than 3/2, and therefore we just write it in terms of x. The modulus of, sorry, x must be greater than minus 3/2 and less than plus 3/2. And that would solve that question. So there we are. Quick summary on the final page. We used the formula in the, for these questions, we used the formula in the formula book on page 2, the general formula, and we have 3 types of question. One of which is a negative index, one of which is a fractional index, and our final example here is some composite problem where there's a factor, algebraic factor on the numerator and algebraic factor on the denominator, which we're going to have to expand using binomial. We can leave the numerator factor alone, and now we've got 2 brackets which we then multiply out using multiplication or grid multiplication, and then they'll ask us to find 1, 2, 3 or 4 terms, and we just pick those out and use those. So there we are. Hope that's of use for you.